All right, so this video, I'm actually going to not only complete the square, but solve using the completing the square. So I did a previous video where I just factored using completing the square, which actually is very important for something that you'll learn, or some of you may already know. But for these videos, we're going to actually solve and go all the way through. So for number 8, again, we need to do half of 12, which is 6. 6 squared is 36, and 23 is definitely not 36. So what we're going to do is create my blank space. And what goes in my blank space? 36, the number we want. Because half of 12 is 6. 6 squared is 36. Okay? And then we still have the plus 23. But if I added 36 to the problem, I also have to subtract 36, right? Because you just can't add random numbers without balancing out the equation. So these need to be the same number because you got to balance it out. And that all equals 0. All right. Here we have our first 3 terms, which is perfect because that makes a perfect square trinomial. And it's going to be k minus 6 squared. Okay, and then 23 minus 36 is going to give me negative 13. Okay, so that would be the factored answer, but I need to solve this one. So I'm going to add 13 to both sides. And it's going to give me k minus 6 squared equals 13. Square root both sides. And I'm going to get k minus 6 equals, and if I add the square root myself, for a number, I need to make sure I write plus minus radical 13. And at this point, if you get a number under the radical and you can simplify it, please do, but 13's prime, so it's not going to work out for this one. All right, and then simply, the last thing I'm going to do is add 6 to both sides and get k by itself. And k equals 6 plus or minus radical 13. Now, I know some of you are like, well, that doesn't look nice. But, again, I know that you could change radical 13 to a decimal. And I know that you can make this answer a decimal. And that is why it doesn't factor. Because whenever you factor, factored answers always come out with nice numbers, right? Like k minus 5 and k plus 6. But here, radical 13 is going to be a nasty decimal. So we can't, I mean, you could solve it, but I want you to leave it like this because this is what we would call an exact answer. So just leave it like that. That's the way it is, and we'll talk about more what this actually means if I actually had you make a decimal, where we go from there. But that's how we would leave this one. All right, number 10. Let's talk about this one here. Again, let's take b, which is negative 10. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. Oh, so close, it's 26. All right, well, we got to make our blank space and put 25 in there because that's the number we want. Okay, and if I add 25 to one side, I have to subtract 25. And all this equals 8 this time. All right, so we take our first 3 terms, which is a trinomial, and we're going to get x minus 5 squared. And then 26 minus 25 is positive 1. And that all equals 8. Okay, to get the x by itself, we have to subtract 1, which gives me x minus 5 squared equals 7. To solve this, we have to square root both sides. And that's going to give me x minus 5 equals plus or minus, don't forget plus or minus whenever you take the square root of a number, equals radical 7. And radical 7 doesn't simplify. That's about as good as we can get it. So we add 5 to both sides. And we're going to get x equals 5 plus or minus radical 7 as our answer. Okay? So that's how you solve quadratics by completing the square. And these would be exact answers. If you wanted to, you could make them decimals, but exact answers are usually the best way to go. So that is how you solve completing the square.